In this video, we'll talk about tick rates, client-side prediction, and resimulation. Now, for the first one, we have tick rates. Tick rates resemble how many updates are going to execute it in 1 second. Now, keep in mind, updates is not equal to send rates. Updates meaning it's just like regular Unity update, meanwhile, send rates are sending the packets to the client. Let's talk about tick rates much more deeply. Imagine tick rates as fixed update in Unity, where the default is 50 Hz. Now tick rate is much similar, and it's also run on fixed update. Now let's take a look at a case here. We have the player character movement attached on this player. Now let's imagine our tick rate is 60 Hz. Now because our tick rate is 60 Hz, it means that we are executing 60 updates per second, and that means the move and rotate will be called 60 times in 1 second. Tick rate is not equal to send rate. Now let's take a look at an example for here. So let's say we have a competitive game such as CSGO, Valorant, and Overwatch. By default, they ran around 60 Hz to 120 because they require a precision, and also the game is highly competitive compared to other games. Now let's take a look at another example here. We have Dota and Minecraft. Dota is a competitive game too. However, because we are looking at the top-down view, we don't really need a very high precision. And the player characters also doesn't move quickly. That's why Dota uses around 20 Hz. Meanwhile, for Minecraft, it's also ran for 20 Hz. And lastly here, we have turn-based game. Turn-based game is very rare to update the game information, hence we only need around 1 to 20 Hz. And for example here we have chess, golf, and billiard pool. And let's talk about the client-side prediction. Now let's imagine where we are playing with 100 millisecond latency. When we press D to go right, our player will not move immediately after 100 milliseconds has elapsed. Now let's imagine we press D, right? We press D, this doesn't move, and the inputs get transferred to the host, and then the host will move our player. Then the host will update the position, send it to the client again. So the client will move like this. So in visual, it will be like client sending input to the host will send the position, and that's it. And this is the input transfer authority. Now, and this is really not good for competitive games. Now, don't worry, there's a technology to mitigate this kind of issue. And that's why we're going to talk about the client-side prediction. Client-side predictions let us predict our movement based on our input without waiting on the server. Now, let's go back our player to its original position. Now, let's say we press D, we move to go right, and we predict the player movement. So it will go right immediately, even though in reality, our player is still in this position. And then after the input has been transferred, the host will also move the player to here, and then the reality will also following to the prediction. Prediction also comes at a cost. You are running more updates in just 1 second. Now, let's talk about resimulation. Now, in here we have 2 simulations, which is one from server and one from client. For the server, it's currently at ticks 103. Meanwhile, for client, it's at ticks 101. But there's also another tick, which is at 103. This is the predicted ticks. Meanwhile, this is the real tick from the server. Now, because we are 2 ticks behind the client predicting into ticks 103. Now, what is resimulation? Now, let's say the server sends the data from ticks 102 to over here. And then the server moves to this tick, and the client also needs to predict to this tick. And this is where resimulation comes in. So whenever we receive a new state from the server, a new data, it will recorrect itself. So it will check, oh, I just received a tick for ticks 102. And because of that, I think I need to check the predicted ticks too, just making sure that they are correct. So it will execute ticks 102, 103, and 104 for each step. Now, this is going to be a little bit difficult to understand because resimulation is just like recorrecting itself to avoid misprediction to make sure that the prediction is still in control. Now, let's imagine in a such simpler case. Let's say we are playing a 2D platform here. Our player is in this position, and then we are predicting to go right over here. Now, let's say our input is having a packet loss, and suddenly our player is gonna pull back over here, and that's where resimulation comes in. It executes these ticks again to check whether our player is in the correct position. Now, if there's no packet loss, then the player just gonna keeps moving, and this state will just gonna follows on. All right, that's it for the resimulation, and it's going to be confusing for first time, but don't worry, we're gonna get familiar with it when we are getting on the coding stuff. All right, so for the recap, we have learned about tick rates, client-side prediction, and resimulation. All right, see you guys in the next episode.